All right, I know that the timer isn't finished, but it's 10 o'clock Pacific by my watch. So, hello, hackers. Welcome to Saturday Hacker Day. My name is Taggart. If you're new to this channel, welcome. On this channel, we do security, we do computer programming, we do CTF sometimes, and on Saturdays, we do blue team work. So, we're going to do some defensive cybersecurity training today. But before we get started, as always on Saturdays, we are going to start with the week in cyber news. There was a lot this week, and I had to do a little bit of curation just to make sure that we didn't spend the entire show talking about news. So we'll hit the top points. Before we get into the news, I wanted to start with a bit of a sad announcement for the cybersecurity and the information security community. We got word this morning that Dan Kaminsky, a longtime contributor to DEF CON, discoverer of DNS cache poisoning, basically just one of the brightest lights in information security, has passed away. Now, I didn't know Dan, certainly personally, and I'm only now discovering how profound his impact was on the information security community. But if you have a moment today, I highly recommend looking up Dan and seeing the kind of work that he did and the kind of person that he was. By all accounts, he just absolutely was the exact kind of person that you want to know and have mentor you. Always kind, always happy to pick you up when you're down and encourage others in pursuit of their ambitions. So if you're on Twitter today, you're going to see a lot about Dan Kaminsky, and I think it's a good idea to learn a little bit about the impact that he had on where we are today. All right, moving on to some other news. This one comes from the University of Minnesota, and I kind of can't believe this story. Um, the Linux kernel has banned the University of Minnesota from contributing kernel code. Now, it's an open source project, but they are banned because they intentionally submitted malicious code to the kernel. According to Bleeping Computer, the move comes after a group of researchers were caught submitting a series of malicious code commits that deliberately introduced security vulnerabilities into the code base as part of their research activities. I can't stress how dumb this is and just reckless. Um, we're talking about the Linux kernel. We're talking about one of the most important pieces of software that's used across all kinds of devices today. Imagine if the university had introduced successfully a kernel commit that introduced a vulnerability into, I don't know, a medical device or an industrial control system that was then able to be compromised. Just imagine the repercussions of that. It was unbelievably irresponsible, and in my opinion, they deserve to get banned. Because if that, I don't even understand how something like that got past an ethics board for research. But if it did, and everyone thought this was an okay move, yeah, no one involved with that project has any business contributing to the Linux kernel that in that shape or form. All right. Next up, we have yet another. I know this sounds like old news, but it's not. We have another zero-day flaw for the Pulse Secure VPN software. I kind of, again, it's like, don't you do more code review after the first 0 day? But it turns out that a 0 day impulse has been exploited by nation state actors to launch, according to CISA, the Cybersecurity Infrastructure and Security Administration, launched cyber attacks against defense, finance, and government targets, and also targets in Europe. The CVE is numbered 2021 22893, and it's a remote code execution bug allowing admin level access to the appliances in the wild. And it's being exploited right now. So if you do have Pulse Secure VPN appliances, please, for the love of all that is holy, patch them immediately. Don't stop. Don't keep watching this. Go patch your VPN appliances if you have them and they haven't been patched, because they are getting attacked right now. This is it's hard to keep track. I think this is the third such RCE that Pulse has dealt with in the last, let's say, 18 months. And what we're seeing across the board is that these attackers and researchers are really targeting these network edge devices, right? As a matter of fact, I'm not reporting on it much today, but there was also a 0 day reported for the Sonic Wall uh, security appliance family. So anything that's on the network edge is essentially ground zero for security research and for especially nation state attackers to develop 0 day vulnerabilities and go after them. Because if you can get past that firewall, right, you're in. So that's something to be aware of, and it's why we talk defense in depth is a buzzword, but it actually really matters, right? You cannot rely on your network edge to be your first and last line of defense. It just isn't going to work. Somebody's going to get in, and once they're in, what do you do from there? Do you have honeypots for them to get trapped into? Do you have DMZs? Do you have network segmentation to make sure that they can't pivot through your network? Are all of your internal endpoint policies correct, like password strength, and are you disallowing SMB1? All of that stuff really, really matters. It isn't just about setting up the firewall and forgetting it, which hopefully everybody on this stream knows that, but I've definitely encountered that point of view in my career where it's like, well, we have a firewall. That's not enough. Or my personal favorite was, we have a firewall and all of our endpoints are maxed, so we don't even need antivirus. Don't be that organization. And I swear I had another story in here, but no. I guess the one I was thinking of, I don't have a slide for it, but the other thing I wanted to mention is that the CodeCov story from last week is continuing to develop. So CodeCov is a service for cloud-based testing of your code and for code coverage, right? And we're talking about a supply chain attack here where their source code was compromised and the uploader tool that they provided to customers was actually compromised, and malicious code was sent to their customers. Credentials could have been leaked, malware could have been installed. It's really, really, really ugly. So I just want everyone to keep an eye on that story, because it turns out that as the story develops, that CodeCov had more and more customers and more really kind of important customers who could have been compromised by this. So we're not quite up to the level of the SolarWinds, I'm sorry, the Enable, because they just changed their name this week, story. But it is yet another supply chain attack that we really need to take seriously. All right. That does it for the news this week. And so this week we're going to dive back into Security Onion after the long and arduous journey of getting Security Onion up and running. It is running mostly on our system. There are a couple of things that need to happen, although I'm going to actually work through how to fix them today. But today's primary objective is to install malware on our endpoint. We have our Windows endpoint that's phoning home to our Security Onion instance. It's in an isolated network. And what we want to do is we want to pick some curated malware from the malware store. That's not a joke, that's a thing. and we're going to install it and see what happens. We're going to see what we can see. That's right. We're going to use Flare VM as our kind of test VM, and we'll kind of go through how to set that up. And yeah, I'll be quite honest, I don't know what's going to happen here because, well, I didn't have time to test it live this week, friends. So we're doing it here on the show to see exactly what happens. Let's get into it. So the first thing that we need to fix is the IP address of Security Onion, which I should have seen coming but didn't. So we let Security Onion, let me get the tunes back. There we go. So the first thing that we need to fix is the IP address of Security Onion. Let's just take a look at our setup here for a moment so we understand everything that's going on. Now again, I'm using Hyper-V, and I'm using Hyper-V for reasons. VirtualBox was giving me way too much trouble, and I was able to get everything working on Hyper-V. But you can essentially, if you're working with VirtualBox, you should be able to reproduce this same sort of situation with VirtualBox or VMware Workstation, whatever your hypervisor of choice is. KVM if you're a psychopath. Perryman, thank you so much for the follow. Welcome aboard. 138. Is that THX 1138? Okay. So we have Flare. Let's bring up our Flare machine. So this is just a Windows machine, except we've used the Flare VM PowerShell script to kind of turn it into a malware analysis box. Now we're not technically going to be doing malware analysis today, unless something goes really off the rails. But we did use it to just kind of configure it to have everything that we needed. And the other thing I did, and this is one of the reasons I really liked using Hyper-V for this, is because of the checkpointing, right? So I can set up my Flare VM and checkpoint it, like I can save my game, right? And then I can install evil on it and ruin my day, and then just go back to the point where before I made mistakes. So that's kind of what we're after today. So you watched the PancakesCon talk? Oh, thank you so much. Lazo's talking about, yeah, in PancakesCon 2020, it was my first talk ever actually at an InfoSec conference. If you don't know Leslie Carhart's PancakesCon, right, it was kind of a split 2020, so 20 minutes on security, 20 minutes on something totally different. And I did my 20 minutes on Jupyter Notebooks for security. That was the security side. And then the other side was I did 20 minutes on elbow strikes in martial arts because we had just gone into lockdown, and I was like, what are some things you can do to stay active and fit in your house? And it turns out elbow strikes don't take up a lot of room. So that's what we did. Still trying to get elbow strikes into our defensive strategy. I think if you've gotten down to elbow strikes, a lot of things have failed in your security architecture. I'm just going to say that, right? If you've gotten to the point where you actually have to deploy, this is pretty close quarters, you know, so something's gone really, really wrong. You may consider fleeing at that point as well. More like apparently safe state versus backing up a virtual disk. Yeah, that's a good way of thinking about it. I believe the way that the checkpoint works is it's kind of like a diff. So you have your virtual disk as it's saved, and then you have diff files, and so it kind of goes back to that diff and does a comparison and kind of restores everything to that point. It's not just what it isn't, and this is important. It's not just like a memory snapshot, which you can do with VirtualBox. Right, so it's a little bit more comprehensive than that, which is why it's not just safe state. It's not just the memory part of it. It also does involve what's going on with the disk. Unless I'm totally wrong about that, and if somebody knows better than me, please correct me. But I believe that there is a disk component to the checkpoint. So that's kind of, in fact, let's look it up. Let's not guess, right? Yeah, no, it is disk related. I believe it's keying off the system restore capability in Windows. Yeah. It's super useful for research. Absolutely. Between that and the trick you can use to rearm the eval version of Windows, you can get 90 days out of one of these things without having to pay for a Windows license, which is nice. And then, you know, once you hit that 90 days, you just go back and you rerun the Flare VM on a new Windows install. That's the other, honestly, I know we're not diving into Onion just yet, but that's honestly the other reason why I'm using Hyper-V is this button right here. Quick Create. And then Hyper-V gives me this button to just like install a Windows machine. Just do it, right? And it'll pull down from the Windows eval, right, to get me what I need and just like have all my configurations ready to go. Similarly with Ubuntu, it'll actually pull an Ubuntu box right out of the sky for me. That's really handy without me having to maintain an ISO library. Really, really nice. I can, of course, do a local installation source as well. And if you're really, really cool, you can use Vagrant. I think, did I do one of those? GitHub/. I think I did. Repositories. I do too much on GitHub. Is this by... Was it a gist? I did a... Huh. I'll have to go find it, and I'll make sure I put it on Twitter for everybody. I definitely did, and I don't know where it is right now. I did a script for Vagrant to configure like a Kali machine without you having to do anything manually, and just like it configures it the way that I like it, with all of the stuff installed, the Brave browser, Terminator, all that cool stuff. But you can do, Vagrant can use Hyper-V as a backend, so you can script out your virtual machine configuration without having to manually do a whole bunch of stuff every time you bring up a new VM. Vagrant's really, really nice for that. Okay, let's talk about Onion, shall we? So, Security Onion, last time we were working on this, so we have our Security Onion machine running. Here it is in our SSH window, and let's just run SO status to see what's up with it. I don't know what's going on with last alert and playbook, but that's okay. Everything else is kind of running. I actually think I know what this might be about. It might be about the IP address issue that we're facing everywhere else. So what we're going to do is fix that problem. Now, last time, right, when we configured everything, this thing had an IP address of 115, but I, like an idiot, just left it up to my local network's DHCP. And the way that Security Onion does its site redirecting, this is essentially the host name that's going to try to redirect to now, 115. And that just doesn't work, right? Because that's not its IP address anymore. It is, I believe... it's 104. So if I try to go to 104, what you'll see happen is it will either fail entirely, but what should happen is like it'll redirect me to 115 without me doing anything. This will turn around and turn into 115. Or it'll just not work. Okay, that's different. Try that one more time. Yeah, I think it's just like failing entirely now, but I believe it has to do with us having to reset this IP address correctly. So how do we do that? It used to be the case, and this is like old Linux stuff. It used to be the case, especially on Ubuntu machines. Okay, can I not clear the screen? Oh, there it is. So you saw that it went to 115 here, which is not helpful. So it used to be the case that you would put things in Etsy network interfaces, but it's not there anymore. And this is Ubuntu 18.04. So like, what do you do for 18.04? The answer is you have to use this thing called NetPlan. Netplan is a YAML file. Well, it's a tool that works based on a YAML file to configure your IP addresses. And if you have that kind of older experience with Linux, it's a pain to do differently. But once you get your head around it, it's actually really, really handy. So we actually have to set up two different IP addresses, I think, because we have two networks that the Security Onion machine is connected to. We have network 1, which is to the internet, right? And then network 2 is the closed loop network that our Flare VM is connected to. And we're doing that specifically so that when we install malware, it can't actually phone home. I don't want it to be able to do that. I don't want the command and control of anything that's still active to know that I'm experimenting with it, you know? So for this particular research, I want to keep it a little bit more isolated. So I have to set up both of those IP addresses. And the other reason I need to set up that second IP address on the Onion is because that's the listener for Waza. Now, we installed Waza last time, but let's review what it is. Waza is essentially open source EDR, I think would be a good way of thinking of it. It's at least log forwarding, right? So it's sending event data with alerting to Security Onion, and Security Onion with Suricata and all the other stuff that's running on Onion is going to kind of process it and disposition it. In order for it to do that, it needs to have that internal IP to phone home to. So we got to set up that. That IP address is supposed to be 10.10.1.2. Is that right? No, 10.10.1.1, I believe. Because the Flare machine is .2. Yeah. .1 is going to be Onion. So we got to configure that. So let's go ahead and get Netplan going. Now, if we look in Etsy Netplan, that might be a little small. Let's zoom that in a little bit. There is the YAML file that's kind of pre-made, and we can, if we want, just re-edit this, or we can make additional YAML files. Notice this pattern of like 00, we can do like 01, and Netplan will apply them in turn, as long as they don't conflict. But I'm just going to go ahead, I'm going to be lazy, and just edit that one. Etsy Netplan 00 installer. Okay, so you can kind of see that I've got Ethernet's ETH0, DHCP4 is set to true. Nope, that's not right, because we're going to set it to false. And instead, we're going to use... Let me split this off and turn it into its own window here, so we can have both of these going. Oh, DHCP no? Why would it be no and not false? If it, yeah, I think it is false. I think that's wrong. And we're going to do addresses. You can add more than one, right? Oh, I gotta set Vim is being weird. For YAML, if you're using Vim and you're editing YAML and you don't have a preconfig for it, you want to set your tab space to 2. Otherwise, still with that? All right. Yeah, see, when I tab in, it goes to the right 2 spaces. That's what you want to do. Okay, so here we're going to do 192.168.1.115. So I'm going to reset it to that. And then we'll set the gateway 4. That's really annoying. Oh, gateway 4 isn't a list. It's a single gateway, of course. 192.168.1.1. And name servers. Yeah, we'll just use the quad 8s. We'll just use the Goog. Oh, so Goog is, this example is using Goog and OpenDNS. Yeah, sure, why not? Spread the love around. Okay, so that's our first one of these. And I cannot remember what the other Ethernet devices are, so I'm just going to save and quit this. and then get that information so I don't forget it again. Okay, so it's real nice. It's ETH1 and ETH2. I thought for a moment that it was doing like weird interface names like NPOS83 or whatever. But no. We've got ETH1 and ETH2. That's real handy. So ETH1, notice that this is our promiscuous interface. That's not a bad thing. We're not interface shaming, okay? This interface can choose the lifestyle that it wants, and that's totally fine. But that's our packet capture interface, right? So we're not going to, I really hope they change this terminology soon. But anyway, this is our network capture interface, and we don't give it an IP address. It's up, which is fine, right? Because it's going to just be listening for everything once we set that up. But we do want to give ETH2. This is where 10.10.1.1 is supposed to live. So we're going to go ahead and give it that. So we'll go back into the netplan config, and we're going to, I'm just going to yank all this. And paste it. Will that work? Yeah, it should be like that. ETH2. Yeah, okay, so here it's going to be... Oh, /25 would have been wrong. It's a 24 subnet. .10.10.1.1. The gateway we don't actually need because it's not going anywhere. And it doesn't have any name servers. It's stone stupid. It's just an address. So we're going to leave it like that, and hopefully everything looks good. Now, we actually have some tools. Is everyone clear? Yeah. If we do netplan help, it'll give us a little bit. So sudo netplan try is really nice because it'll test the config and it'll tell you if you messed up. Now, if that worked as intended, I will have lost my SSH connection, right? Because I no longer have it to the right IP address. See? But if I go to 115, the host key verification failed, but that's actually good news. I gotta edit this. Just blow these away. That's what's up. So now, let's take a look at our... Well, let's look at SO status. I wonder if this is better now. Sudo SO... We're gonna run last alert restart just to see if we can get it to fix itself, and we'll do the same with playbook just to see if we can bring them back up. But meanwhile, let's see if we can get to the Security Onion web interface that we weren't able to get to before. Okay, so that's how we fixed that. We were even warned when we set up Security Onion, like, hey, don't give this a dynamic IP address. You're going to have problems. And I was like, oh, okay. I should have cared. That's not the right email address. All right. While this thing is sorting itself out. Oh my. We might have to just restart the machine. In which case, fine. Let's do that. I'm just going to kill this connection. I'm just going to restart the Onion device. I didn't even hit reset and it died, so that's fine. We'll just reset it here. Meanwhile, let's talk about where malware comes from. When two computers love each other very much, no. Malware Bazaar is a great resource for exactly what we want to do here, which is get malware, install it on something, run it, and test it. Look at how many submissions there have been in the past 24 hours. So we can search for anything. Hey, chat, any suggestions on the kind of malware we should install? It has to be Windows, right? We're not going to do APKs, but other than that. Shout out some malware that you know. Maybe we can do Dridex. Oh, I'd have to do tag Dridex. Or tag emotet. These are always fun. Now, I do have Office installed, so if we wanted to do a maldoc, we could do it and see what happens when we, enable macros. Ghost. Panda Cat, what's Ghost? Oh, Ghost Rat. Right. Brand spanking new. All right, let's do this. Now, one thing that's pretty cool is you can kind of see what happens on any run. Oh, good, no threats detected. Awesome. But Joe Sandbox found it, and you can kind of see what the write-up was for each of these. But we can also download the thing ourselves. Download sample. Now it's going to be zipped, obviously, and we're not going to unzip it on the host machine because that's do you want viruses? That's how you get viruses. But there's also a nice Yara indicator that you can grab for this as well. The other thing that I might do for something like this is, unless there's a cool link to it here. Oh, this is nice. Look at this cool behavior graph from Joe Sandbox. Thanks, Joe. And this might give us some hints. So starting to sweat. Think I'm allergic to malware. Get the fork test. Right? So what you do, right, you go to your doctor and say you want to get a test for malware, and they'll scratch with a fork, right? And then they'll put like emotet on one of the scratches, they'll put Ghost on another, they'll put Dridex on another, and then wait 24 hours. And if you start phoning home to any of the command and control frameworks that we know about, then, and then you'll carry an EpiPen or something like that. So the other place that we might want to check out is the Alien Vault Open Threat Exchange. Just so if we're going to do this research, we want to know what we're looking for. You know what I mean? So, no Scandroid. So with the Open Threat Exchange, you can look for things like Ghost, and it will look for what are called pulses, which are submissions from the community of malware indicators of compromise, indicators of attack. Right? So this was from 13 days ago, and let's take a look at what this user submitted for us. So we have a bunch of domains that we want to watch for, right? yk.getshell.org. No, that's not suspicious at all. I do have a detection at work for weird looking domains, and .xyz is one of the TLDs that I look for. It's nothing good. You ever hear there's a good Chris Rock bit about like nobody's getting money out of an ATM at like 3 in the morning for anything good. Like nothing productive is happening with that ATM cash at 3 in the morning. That's kind of how I feel about XYZ and a few of the other top level domains. Like nothing positive is happening on those domains, right? Maybe consider blocking them entirely, but definitely. Footpix loves yk.getshell. Visit that every day. Well, I mean, where else are you going to get your shells? It's right there in the name. I think they bought Shells R Us. Okay. Onion. So that looks better, right? We're not seeing any errors. Playbook and Redis are starting, which is fine. So it turned out that IP actually really mattered. But so this is kind of nice to look at, right? And you can you go to related pulses. You can see all sorts of cool stuff here. I highly recommend if you're in the defensive realm, get yourself an account. They're free for the Alien Vault Threat Exchange. And they will send you emails about new pulses that are interesting and getting a lot of interaction. So real handy here. I think you can like, let's see if we look for pulse, right? There should be, even though they're called pulses, like if we look for pulse secure, maybe that's a better one, or pulse VPN. Because in addition to what you'll get from this is, yeah, here we go. Right, this was from yesterday. So there are some file hashes that you want to look for. Here are your CVEs. Sometimes with these, though, what you'll get, which is I think really cool, is you'll get IP addresses of the attackers that are exploiting the 0-day. Yeah, here we go. Like suspected APT actors right here. Let's go look at... Are they all... They can't all be file hashes. Okay, some of these are Yara rules, which is good. So, okay, so essentially... Got it. These... If you read, I don't know why you'd read, but if you decided to actually read what was going on here, what you're looking at are file hashes of the web shells that are getting installed by the bad guys. So, you know, you can take these file hashes, throw them into your detection tools, and, you know, do a check for them. If you could also, for example, run them against, like, Loki. Yeah. Right. So you can take Loki, give it a Yara rule that looks like that, and check for these web shells against anything that you're concerned about. Anyway. Let's see if I can log into this thing. Not gonna lie, I was a little concerned I had forgotten the password. We're gonna just add that to LastPass. Okay, so now that we're in here, and we should still be getting data from our Flare machine, because now that they're both up, let's check here. Let's go to Kibana. Yeah, last 24 hours. Let's see. We want to see. This is all Zeek stuff. This isn't packet capture, though. Oh, I guess it is. But it's only to... Yeah, so the packet capture is working kind of. It's working for our machine, right? But it's not catching everything, and that's a networking thing we need to sort out. But let's look at Waza and see if there's... Okay. So there's Flare. Not a whole lot yet this week, but that's okay. We're able to filter it by the name. This is also, you know, where are we? We're in the dashboard. If we discover, right, this is a little bit more open. Yeah, see? Now we can see some stuff. Yeah. The dashboards are like... They're probably not configured correctly. I haven't gone through and set up the queries the way that they should be. But if we just go to straight discover, this is like... Exactly right, PandaCat. Exactly right. This is like your default search in Splunk. So we're getting data. That's great news. All sorts of... Yeah, Windows event logs. What sort of event IDs are we seeing? Event 002, that's not, you know, the most interesting. Event, oh wait, is it event code? That looks more like what I was expecting. I was like, what's 002? 4624. Okay. Quick quiz. 4624. What Windows event ID is that? There are certain, if you're going to do Windows-based detection or defense, there are certain Windows event IDs that you want to know by heart. 4624 is definitely one of them. PandaCat is correct. It is a successful authentication. So if we add this, 4625, by the way, is an unsuccessful authentication. So from a detection standpoint, one of the things you want to build like right away is really look for spikes on 4625, right, of from a specific user or from a specific IP, which can indicate password spraying or credential spraying or credential stuffing. Sorry, that's something that you want to detect for. And then we'll use... Because this is so well parsed, we can look for the target username. And we'll toggle the column in the table. You see how once we add columns, we can start making our table a little bit cleaner. Really, really nice that way. So we can see that all of the logins here were from system. Now that doesn't tell us a whole lot because the agent, the Waza agent, is ostensibly running as system. Oh, sorry. It's actually, that's also because I was looking at the wrong dang field. The subject username is what we really care about. Or the target. The subject username. Whoops. What do I want? I want the subject username. Okay, so what we're looking at here, so we see the subject and the target username. These are reversed, but whatever. Oh, move column to the left. That is, okay, that right there is a feature that I really wish Splunk had, and it doesn't. Reordering columns is a huge pain. So what we're looking at here is the machine account using system. Essentially, it's running stuff as system. And we could look in more detail. Hey, the Guar, good to see you, man. So you can see process name too, right? It doesn't, perhaps unsurprising, what we're seeing here, right? That it's services, ADV API. Look at the timing, right? It's always hard to look at the timing. I don't know about you, or maybe it's not for you. For me, sorry, I got like a frog in my throat or something. For me, it's always difficult. I want to dive right into the technicals, but it's a good discipline to start with the story. Meaning, if we're investigating something, right? What happened when? And so, let's look at our timing here. So we've got something at 10:30, 32, 34, 36, and then 40. What do you think we're seeing services? How would we explain this data? What are we seeing take place here? What are we seeing take place here? I don't know for sure, but I have a pretty good idea that this is services starting up, which would explain why we're seeing everything coming from services.exe. We're seeing the machine account impersonate system. And that's what happens when you bring services up. Winninit.exe is going to be firing up all of these things, right? So that's what we're looking at, I believe. Okay, let's clean this up. All right, enough faffing around. Let's install some malware. Gulp. All right, we're going to download this sample. The password is going to be infected. I'm going to save it to, I just made this folder for malware samples. And then on the Flare machine, where we're going to do our testing, going to make sure that Defender endpoint is or real-time protection is off. It likes to turn itself back on. I'm turning it off because I want the malware to do its thing for right now. I have every confidence that Defender can detect it, right? This is a known submitted sample. It's not going to be difficult to detect. But I want to see what it does, what Windows events in particular it generates, and what network traffic it generates, to see what Security Onion can do with it. All right, so there it is. Now, in order for us to capture network traffic, there is actually one other thing that I need to do, and I need to look up how to do it, which is right now. Let's look at Security Onion and the virtual switch manager. So the Isolation Lab, which is one of the networks I have, it's a private network, and extensions. It has capture enabled. I have to enable a span port, though, I believe. I think there's a way. I think I have to specifically tell the virtual network interface to, well, it's in promiscuous mode, but I have to tell the switch to mirror ports. This is meant to be, I want to be clear. Does anyone need a refresher on span ports, mirror ports, and basically how you do packet capture in real life? I'm going to do it real quick just in case. Okay. This right here is a Cisco 3850. It's a Catalyst switch. I love these things. There are newer ones, but I don't know. I cut my teeth on the Cisco 3800s. I deeply love this hardware. And what switches do, right, and we're just basics here for networking, what switches do is that they distribute link across multiple network interfaces. And they do it to the best of their ability in parallel, which is different from an older technology called a hub, which will do it in sequence. Now, that doesn't matter so much anymore because nobody uses hubs anymore, but if you're taking your Sec Plus or your CISSP, it's going to be on there. So what you're looking at is 48 gigabit Ethernet ports. And over here, you're looking at 4 10 gig ports that can take in fiber. Or 10 gig Cat6 if you're cool that way. But generally speaking, you'll see these ports are configured to do fiber optics. Now, let's say, so this switch, let's say this is the switch that's running our small business, right? And let's say like our router from our internet service provider is like connected over here. And let's say that, you know, my DHCP server is connected here, my DNS server is over here, right? Like I have these different switches. And let's say I wanted to monitor traffic across the entire network. So I plug in my Kali machine or I plug in Security Onion, like right here. The way that this thing works, right, is that it's a layer 3 switch. It knows about IP addresses, but the routing really is at layer 2. Layer 2 is MAC addresses, right? So basically what it does is that when it gets these these packets, right, these TCP IP packets, it'll say, okay, what IP address is this intended for? I have a MAC address table of where all of these MAC addresses are, and ARP tells me, Address Resolution Protocol tells me what IP relates to what MAC address. I have an address table of where that device is on all of my switch ports. So it's like, okay, you want to talk to the DHCP server? Dope. I will route you from there over to where the DHCP server is. So it's not like your router doesn't actually route everything, because the switch is handling packet destination, right? Your router is handling stuff once it gets to the gateway. Okay. So that's how general TCP/IP networking works in one of these switches. Very, very, very fast overview. But what if I wanted to listen to everything and basically say, forget your filtering. You're going to send a copy of every single packet going to every single switch port to my switch port. Well, you can do that, right? It's called a span or port mirroring. but you got to configure it. So there are ways you would do it in Cisco, but we got to figure out how to do it for Hyper-V. Before I move on, was that at all clear, helpful? Any questions? I'm trying not to do stuff that's just like whizzing by. All right, cool. Let's look up Hyper-V port mirroring. Panda Cat asks, do we need to set up a destination port from the switch to us? Kind of. What we need to do is tell Hyper-V, look, the virtual switch, right, you now have a device connected to it, right? And the virtual switch is doing routing, right? That's how we can get the Flare machine to talk to Security Onion at all. But we need to say, look, you need to make a copy of every packet that this thing is routing to literally anywhere and send it to the Security Onion's network interface. The Guar switched to a physical tap at the head end on my network so I won't miss any captures. That's a great move. What a physical tap is instead of configuring the switch that the way we just said, because in a complicated network you'd have to do that in a bunch of different places and it can create a lot of bandwidth bottlenecks. What the Guar's talking about is literally a physical, almost like you were doing plumbing, like a T-junction of the network, and capturing just the whole fire hose. I've even seen there are pretty cool devices that will kind of wrap around a network cable to try to do it that way. That's a little bit more triage-y or just straight up offensive, right? A tap that you're not supposed to have. But okay, so we need to configure it that way. So I believe this is the article I had found. Right, so it's not port forwarding, we're doing port mirroring. Okay, so it looks like I can do it not in the virtual switch settings because it's already set up to allow it. But here, if I look at my network adapter, so hey. Oh wait, if I expand this, advanced features, here we go, port mirroring. All right. Okay, so I want to mirror, do I want to do destination or source? It's a good question. What do I want to do? Yeah, like an old vampire tap. That's literally, yeah, exactly right, Thor. I'm trying to think. Do we want to do mirroring mode for destination or source? Source, right? Because we want to any source on the network, right? We want to mirror to. I think source. We'll see what happens. With that done, let me go back to my dashboard here. I love that we're already getting alerts. Now, some of this is from us, of course, but Panda Cat's looking at Cisco span port monitoring configurations. Okay, so like amongst the kinds of certifications you can go get that mean something, the CCNA has got to be one of the top ones, the Cisco Certified Network Administrator. It's not a popular opinion, but I really believe like you can do all kinds of security work without having a background in IT ops. You can jump in and do security first. But there is going to be so much that you're just kind of floating on the surface of. And if you jump right into cyber from not being in an IT background, I truly believe the most valuable thing you can do for the first month, maybe 2, is not do security, but embed with the networking team, embed with the firewall team if they're a separate team, embed with ops, embed with desktop support. And it gets like, I don't want to do SOC 1 email, doing email phishing all the time. Yeah, well, you know, learning networking means that you will understand a whole lot more of the story about what happens. As we're about to see, right? We've already reviewed a packet capture of some malware. All right. I want to see Zeke. Okay. We'll see what happens. Let's go ahead and run this thing, shall we? Actually, let's test the packet capture, because we can run. Hey Angel, good to see you. We can run TCP dump on, it should be ETH1, just for a second. Angel, we are using Security Onion and a Windows VM. We're going to install malware on the isolated Windows VM, and we're going to see what kind of stuff Security Onion, just kind of out of the box without any extra detections, picks up. And then we're going to see if we can add detections and make it work a little bit better. Right now we're testing to see if the packet capture capability of our Onion machine is what's up. Okay, so we're listing on ETH1. And in order to get some traffic going to it, let's fire up PowerShell here. Oh, wait. That's not how you do ping on Windows. There we go. All right, well, hey, look. We're getting packet capture in from 10.10.1.2. So we are seeing the traffic on that interface. So our packet capture is working. It should be ICMP. Yeah, I don't know why we're not seeing everything, but we are seeing traffic from... Yeah, we're not seeing the ICMP, but we are seeing UDP traffic and we're seeing NetBIOS. It's possible... Oh, you know what? It's possible that the ICMP didn't go through the virtual switch. Or, no, that's stupid. Actually, maybe it isn't. No, it still has to go through the switch. But we are getting traffic. And in fact, let me... If I try to go to something on the internet, it'll fail miserably. Whoa! But it's definitely picking up that traffic. Awesome. Okay, so we're definitely getting the traffic in. That's what you want to see. All right, we'll kill TCP dump. Because obviously we're getting that traffic in. Let's reload this and just see if we see anything new in here in the interface. Yeah, the Guar, that's absolutely right. I saw that too. You can set source and destination. It looks like we're sorted here at the moment. But this is really good to know. Oh, that's actually okay. So if I read you correctly, what actually should be the case here is that this is actually destination. That this should be set to destination. Yes. And then the flare would be source. Now let's see how that changes things up. All right. There's our ICMP. And are we still seeing... Yeah, we're still seeing all the cool web traffic. Okay. I think we got it. There we go. So we had to set source and destination. So if we wanted to clarify then, if we wanted to set more than one of those network interfaces to be captured, right, we would set source for everything. Not quite bridging. Right, bridging, right, takes an external network interface and brings it, like, essentially represents it as a separate physical interface to give you an IP on the same network, right? But it's about, basically, it's just asking the switch to route one packet to multiple destinations. It's like a CC on an email, I think, is a really good way of thinking about it. Okay, so we've got packet capture going. Let's see event module Zeek. Okay, well that's definitely better. We could also look for Suricata. No alerts yet. And if we look, just so we're clear, if we look at Playbook, which is another tool we have, right, we can, let's see if we have any, what are we doing? We're doing Ghost, right? So we don't have any detection playbooks for Ghost, but we could create a new playbook. where this is in Sigma. So if we wanted, we could go find a ghost rat detection, right? And go find a Sigma rule and add it to our playbook. But let's see what it can do out of the box. All right. Infected with the password. Everybody ready? Does it only support Sigma rules? Playbook only supports Sigma rules, but you can add Suricata rules all day long. So Sigma rules, Sigma and Yara are kind of different things. Yara is great for like on system IOCs, which we might get some of. Sigma's kind of for the whole smash, including network. Yeah, you can use Sigma to convert to other rule sets. In our case, we would do it to like Elastic or KQL. Okay, so let's run some malware. All right, Security Onion, what do you got for me? Let's see if there are any, let's just go like straight up to the dashboard and see if there are any alerts. All right, there are some alerts, but it doesn't look like we're seeing anything from All right, let's go back over to our Discover, looking just at our flare stuff. See if there's anything we can see here. Well, that's the question, Angel. We didn't know if it did have anything to alert on. I wanted to know... It has rule sets, and I wanted to know if out of the box it was going to see anything suspicious about what was going on. Right? Because Security Onion comes with a whole bunch of stuff out of the box, right? No. I want it. So let's see. We're getting information. Let's look at... this is just Windows events, basically, that we're pulling in at the moment. So we'll say agent.name, winlog event.id. Let's add that as a column. And we'll do target name, subject username, And yeah, cool. So let's see. We got 4672s, we've got 5379s. What is Windows Event 5379? Let's go find out. Crap. Right? It says Credential Manager credentials were read. Now, I didn't do anything with Office. Right? And it was the user, not system or anything else that was doing that. I didn't do anything with Office. So it read cached credentials from Microsoft Office. Now, luckily, because this thing is isolated, it didn't send it anywhere. That's why we did that. But holy crap, right? So we did find something. A lot of this, a lot of 5379s. Is there a... At the moment, these are just events and not alerts, because what we're doing right now, Angel, is threat hunting, right? We threat hunt first, then we build detections. We'll add logon process name. Nope, that's not helpful. Sometimes the Windows event should have a so it's just in the message, right? The event occurs when a user performs a read operations. So we could see winlog.message if we wanted, but it's probably going to be messy to read. We'll add it and we'll see what it looks like. The first event you saw was that it was deleted. Potentially, yeah. That's going to generate a lot of false positives, but I think you're not wrong. So these are Windows events, pretty much. Now, we're not... And again, actually, this alone, right, the cache credentials being read, that alone is not enough for a detection, because people are that's gonna happen legitimately all the time. What you might want to do is something like, if it is the case that something like this is happening. Okay, this is weird, right? Look at these users. Is it enumerating users? So let's see what else is going on the machine. Net user. Okay, so it doesn't look like I have a whole bunch of new users. No, that's not where I want to be. It doesn't look like I have a bunch of other users on the machine just yet, but definitely looks like it's querying stuff. Now, I'm curious if... I mean, let's just do basic stuff. Let's see if there's anything weird running now. What the hell is this? Is this Defender? There's our EDR agents. Velociraptor still running? That's hilarious. It doesn't need to be running. That was the other story I meant to report on. Velociraptor was purchased by Rapid7, owners and creators of Metasploit. Velociraptor is a threat hunting tool that was on here from a previous run, where it provides a web interface for doing like log investigation, things like that. It's really, really cool. We'll do Velociraptor again another time. All right, so like right off the bat, it doesn't look like there's anything super weird. But we don't actually have enough information. Rapid7 is not just on the offensive side. Rapid7 has Nexpose, and Insight VM, which are vulnerability management tools. So they're really, like, their primary products are, I would say, actually, for the blue team, they make way more money selling to SOCs and to vulnerability management departments than they do. They'll do like MSSP stuff, or yeah. But I think by just like licensing and stuff like that, their Nexpose and Insight VM products are kind of their cash cows. Which is, it's kind of the reverse of like FireEye, where FireEye, they do have defensive stuff, but yeah, Mandiant, you know, their security consulting arm is doing a lot of pen testing, and I think that's probably where their growth is. Okay, so it doesn't look like we're getting a lot of like real alerting here. And I don't know how long it takes Security Onion to like process this stuff. It's not going to be instantaneous. We're getting traffic. $11, $12. Now, some of this is probably going to be a little bit defanged. Look at this, though. We're seeing a lot of traffic to... so if we wanted to look at network traffic, how could we do it? If we go into Discover, we could do something like... Let's clear all of our selected fields here. Can we filter by type? No. This is a yeah. It's all security onion stuff. It looks like it's all Windows events. It's not we're not seeing any packet capture information here. If we wanted to do that, how would we look at that? Okay, so we are seeing it here. So look at this. We have a couple of different destination IPs that we're seeing here. And this is DNS, is our top network protocol. But you can kind of see here that we're getting 224s. This is a broadcast address, isn't it? Uh, 1.2 is the Flare VM. No. Yeah, it's a multicast address. This isn't a real IP, the 224. It's trying to send to a multicast group. Some IP6 traffic. And this 239, 255, I don't think that's real either, but we'll look it up. I think that might be another multicast thing. Yeah, SSDP. You saw LLMNR, I directly thought about LLMNR poisoning. Okay, I mean, fair enough, Angel. The thing is that LLMNR is going to be enabled by default in Windows environments, so you're going to see it, whether it's malicious or not. So what we're seeing here is a whole lot of normal discovery traffic. We're not seeing a whole lot of HTTP or like anything else, really. We're seeing a lot of this kind of discovery stuff, but nothing real coming from it. If we go into the Flare VM and we like try to go, the problem is that the names aren't getting resolved because I don't have a DNS server, you know? So that might be why some of this isn't working. But we are seeing Windows event information. So I think because of the way this is set up, we're going to mostly be seeing endpoint data. So that's probably where we want to focus. So we saw a whole bunch of Office stuff getting collected. Now, we're doing a blind hunt. That's what we saw. But let's actually read up. Are we not getting anything from OS Query? I don't think I set up OS Query. I was focusing on the Waza platform. I don't know if that gives us, I don't think that gives us OS Query out of the box because I didn't install the OS Query agent. But I could. If I go to downloads, right, I'd have to install the OS Query package, which I can do. Yeah, let's do it. Let's throw it in downloads for now. I guess I can't have it. Interesting. Can I download anything? Yeah, So that's interesting. The OS query. Oh, wait a minute. It's possible that's because. I wonder if OS query is one of those things that you don't get. After installation. Some of the stuff in the evaluation version of Security Onion, which is what we're using. Yeah, well, we were trying to remember. We were looking at Logstash and that you couldn't do it. But I wasn't sure about OS query. I don't care about AWS. Do after configuration? No. Is it configuration? Is that what I want? Yeah. Evaluate. I have a feeling that it's not available on here. But let's see. Yeah, let's look at PCAP. This is neat. Gives you access to our new PCAP interface. Access your full packet capture that was recorded by stenographer. Okay, well, we can't do too much with that at the moment. We go to hunt. Let's go to alerts. Do we see anything? Nothing useful. So we just don't have the right alerting here set up, which is fine. What we would do then is get it going. So we know that we installed Ghost Rat on this thing. We got it from Malware Bazaar. So let's go back and see what's going on. We do have a Yara rule here. So it's using urlhouse.abuse.ch. No. It does a web download. No, that's a Malware Bazaar feature. That's not what I want. It doesn't have any IOCs necessarily, but what we can do is let's take the SHA-1 here and go over to virus total and see what it knows. It knows about it. Long sleeps, PEEXE, runtime modules. Okay. Interesting. I wonder if there's a capital S SVC host running. All lowercase. Interesting. Okay, but so contacted domains, right? We might want to look at DNS to see if anything is there. But it doesn't have a DNS server to phone home to, so we're going to be missing some of that. Let's look at the Joe Sandbox report for this to see what else it sees it do. Angel, I can't because it doesn't have a DNS, it doesn't have a name server configured. It won't go anywhere. If I configure the DNS name server to be 10.10, which I'll do. I always hate getting to this thing. If I give it like 10.1.1 as the name server, the requests will still fail, but they'll show up. I'm not running SimNet. I don't know what SimNet is. Tell me more. Is this what you're talking about? If so, no. Oh, Flare has something to simulate. Interesting. Can simulate network services. That's cool. Well, even without that, if I'm pointing it at this thing, even though I don't have a DNS service set up, it should at least pick up the packets. Let's try to make it go someplace. That's fine. Nothing yet. Okay, let's take a look at what Joe Sandbox is saying about this. Okay, so command line runs runjnqu.exe. And then that's plainly creating a service, because then everything else is happening under service host. MP command run. Defender. Oh, kills defender. Interesting. Okay, well, let's see what else we can add to the endpoint to get more telemetry. One of the things that I know that I should have installed but didn't is Sysmon. iNetSim. FakeNet NG, an open source network. FakeNet NG allows security as. Oh, okay. It might be in the Python folder then. Just net. FakeNet NG, there it is. Okay. So what we'll do, I think... So it's getting domain requests. The problem is that it's gonna... You need to configure what to listen for. I think I want to get Sysmon on here first before we go any further. So the way we're going to do that, I should have... Do I seriously not have sysinternals right now? That seems impossible. Apparently not. All right, let me go grab sysinternals real quick. I can't believe I don't have it. Can you please just give me the download? There we go. Oh. It is there. Whatever. Show folder. So what we're going to do with that is we're going to install Sysmon. To install Sysmon, let's actually go down to the Sysmon documentation here. There we go. And actually, we're going to... Great. We're going to revert this thing. Let's... We're going to apply this checkpoint, go back in time just apply. We don't want to create the checkpoint. So we're going to go back to before we applied the malware. And try all this again. But we're going to install sysmon. Using sysmon with Elastic has some nice graphs for process events. Yes, I have seen that. So sysmon takes a config file. Man, I thought for sure, I thought this was the funniest thing. Somewhere on here, I thought that Swift on Security's own configuration file was actually in the official Microsoft documentation. I swear it is somewhere. But either way, Swift on Security, which is an obvious follow, obviously, provides a pretty cool sysmon config out of the box. As you can see, there's a lot that you want to track and a lot you don't, right? So look at the exclusions that we're not tracking everything under the sun here on Windows, because otherwise the logging would just get crazy. So this is a good starting place for your exclusions. Okay. So we're going to get this raw and save it. We're going to save it to the same sysinternals folder. How's our Flare VM doing? It needs to be on the isolation lab. And we're going to have to reset that network interface. How far back did this go? Pretty far. Crap. We're going to have to redo the install of Waza too. But actually, that's not the worst to redo that. That's fine. Well, we didn't break something so much as, a little bit. Yeah, did you find a threat? What did you find? No, that's not real. That's Flare. Let me mute that so it stops. It looks like the revert took away a bunch of the stuff that we had, which is surprising to me because the 17th was... Oh, I guess the checkpoint was from... I thought I created another checkpoint this morning, but I guess I didn't. It was from right before we installed everything, which is fine. We can go back and do it again. That's no problem. Yeah. Trying to think what we need to do. First, let's get sysmon going. It's kind of what we're in the pipeline doing now. we'll do scripts, sysinternals, and go get sysmon, and the config. Go ahead and throw these on here. I'm actually surprised that sysmon isn't running. I guess from Flare. Let's just confirm that it isn't. With some PowerShell here. This is something I'm trying to get really, really good at, which is using PowerShell to read the logs rather than the Windows Event Viewer. Yeah, max events, right? Okay. Now let me just make sure for my own sanity that I didn't get the log name wrong. I'm pretty sure I didn't. Microsoft, Windows. Okay, yeah, so confirmed. Flare doesn't install sysmon. Good to know. So what we're going to do here to install sysmon is sysmon -I and -C for updating the configuration file. Or no, just I and the config file. We don't have to also patch -C. That would be to update it. So sysmon 64-I and point it to the sysmon. Nope. And now we have sysmon running. Okay, that's good. Why don't we, all right, now let's go get Waza off of our Security Onion downloads. I already have it. There's the Waza agent. Let me go get that and toss it in here. And we'll run the agent configuration service. Now this is pretty cool. I have to go get the auth key from Security Onion, so sorry about the bells. Agent manage. Can't type. We're going to extract a key for an agent. It's going to be 2. .1.1. There's our registration key. We got the correct agent name, so we know it's working. So the status is stopped, which means I have to I think it's called the OSSSec agent. Or is it actually called Waza? No, it is. So we're going to start it. And that gives us the service running. Now it's running. Okay. So we should be good. We should be getting stuff now. Let's not make that mistake again. It's nice and clean. So we're going to checkpoint this thing. I need a sound box for checkpoints, don't I? No, that's not good. What game had like an actual checkpoint? Like it said, checkpoint. What game was that? You were hunting for some IOCs? Was there a question? I was just curious. We just set up a new checkpoint, so that whole problem wouldn't happen again. By the way, you can kind of see how this works, how the checkpoints are diffs from the original. Checkpoints are snapshot. Well, again, they're snapshots, but not just of memory. They're also of they're of disk, and think of them as diffs, almost like Git commits in a way, where they have the differences from the last change. So if you look at this checkpoint tree, right, this is like when the machine was created, the VM, then we installed it, then we did a whole bunch. We set some other checkpoints up, right, where this is where I set it up to be Flare, and now. This is where I set everything up before we installed malware on it. And we're still getting data. We should still be getting data in. So we've got sysmon going. We've got logs going in. Let's go back into Security Onion and see if I have a problem with browser windows. And see if we're getting sysmon data in. Let's look for filter for event ID. 5379. Now, Waza should, by default, let me see. So how to monitor the Windows event channel with Waza. So I think we have to configure it. Oh, included in the Waza rule set. So sysmon should be set up to be collected by Waza out of the box. Let's just go ahead and check out our Waza log to make sure everything's configured the way we would expect. No, it's not going to be. Why? Because it has the wrong IP address. Hold on a second. Windows 10 needs to fix this. There can't be 10 different places to set up things. 10.10.1.2. Okay, network's up. Let's re-snapshot that to here now. So we're actually going to delete this checkpoint. And make a new checkpoint. With the right IP configuration. Now, back over to Security Onion. Okay. Now we're seeing stuff. God, that's a lot. I think we're about to explode the event count because of Sysmon. Alright, so obviously this win log event ID isn't useful. Process. Okay, here we go. Sys collector. Let's see if our discover, our dashboard does any better now. See if we have any, like, do we have any Sysmon? We do. We have a Sysmon dashboard. Although it doesn't look like we have anything just yet. I want to confirm. Let's go confirm that Sysmon stuff is configured to be collected. To do that, we're going to go C program files. It's called the OSSec agent and logs. Nope, just kidding. OSSec.conf. Let's look at our configuration file. I'm just gonna look for Sysmon. That sucks. All right, so was it case sensitive? So here are all the log files that it's set to do. It's doing security, right? So we're going to add something to it, right? We're going to add Sysmon to it. And let's restart the... Nope, not that. Let's restart the Waza service. Okay. And then let's also open the waza.log, or the osec.log. So we just started it up and it's saying it's monitoring these registry things. PowerShell. Let's see if it's yeah, it's running. Okay, so let's see if we're getting anything new from that. Okay, yes. Microsoft Windows security auditing. Windows event log. Anything in Sysmon? Not just yet. Oh, interestingly, that we're still seeing credential manager stuff from Office, so that might have been legitimate. It might not have been actually anything evil. We're definitely seeing stuff from Sysmon, though, so it should be coming in here. Oh, wait. Hold on a second. Did I copy pasted this, right, and it was the wrong location? Wasn't it? Yup. Well, let's just see. Let's actually see if the log... Yeah, it won't reload the config, presumably, unless we restart the service. There it is. Okay. Okay. Close you. I gotta get rid of some of these windows. Or these tabs. Yeah, now we can hunt. These look different, though. Oh, this is neat. Click to create a case in the Hive. I mean, this definitely looks like different kinds of data. I don't know. ID, was manager, full log, process end. See if our log's showing anything else here. Yes, I do. I wonder if it just takes a minute for it to evaluate everything and then send it off. But I'm also wondering... We're definitely getting more than we were before, right? Because just the rate that this is increasing is significant. But we're not... Let's read some more about how this works. So, the channel... Yeah, no, this is looking right. And it's saying that it's getting sysmon. But it's going to be coming in to this. I bet it's because we're sending it through Waza that Security Onion doesn't know what to do with it. If we were to send it through WinLogBeat or something else like that, it probably would work a little bit better. Alternatively, this is something that I need to learn, which is... Okay, get started with sysmon. We have... Are there plugins to with Splunk to transform the log types? Maybe? I do want to throw the logs to Elk. But I don't want to have to do it... Oh, a second. By a group policy, because I don't... Do we have to do it there? Let's see if we can do it from the local policy. No, not security policy. Edit group policy. That's what I wanted. I was like, this doesn't look right. Okay. Administrative templates. Oh, let's also, while we're doing this, so we're trying to forward the sysmon logs like straight. Now, that's one. Two is we need to make sure that that Security Onion is set up to ingest it. which would be, I think, syslog. 10.10.1.0/24 we'll set up to allow. Okay. Now, administrative templates. Windows components, event forwarding. And we're going to do... be like server equals... Huh. No, because it's from the DC. This is only supposed to go to... This is only going to do it through... It's not going to do syslog. It's only through Windows event forwarding to a domain controller. That's not great. Oh, all right. Well, let's see what it has to say about sysmon. Windows event... If you're shipping sysmon logs via winlogb, configuring the winlogb configuration does not use the Elastic Sysmon module, Security Onion will do... Oh, interesting. Well, let's read this. With free SolarWinds event log forwarder for Windows, guess what? I'm not installing a SolarWinds event log forwarder. Can I just get this? Nice. Wow, this is a lot. So how do we get log forwarding? I mean, Waza should be doing it for us. I'm annoyed that it's not. Let's do a quick, just a straight up search for Waza sysmon. Yeah, they're now called enable. Except that it looks to me like it doesn't look like enable. It looks like enable. Right? It doesn't say enable to me. And it also, I don't know about you, but it makes me think about the Nokia Engage. Some of you might be too young to remember this thing. God, that's an upsetting thought. Chat, who remembers the Nokia Engage? This was like the first gaming phone. It wasn't good. Side talking. Oh, yeah. Woof. I didn't have one of these, but I did have a Cyberco. I, like, hoodwinked my dad into buying one of these. Instead, I was like, I'll learn how to program on it. That never happened. I'll keep track of my homework. That also never happened. There was also, like, a semester in high school where I tried to take all my notes on a Palm Pilot, and that did not work. Yeah, so it used to be these things. This is actually like the exact model that I had. The there used to be this like zone that you would write in, but the thing that Palm Pilot had its own like its own alphabet basically. Like you had to learn how to make letters for the Palm Pilot. The graffiti alphabet, that's what it was called. Yeah, you had to learn how to write like this. Look at this E. Like, are you kidding me? It was basically shorthand. Okay. Back to what we were doing. We're trying to do... Here we go. There might be an issue here in Reddit. All right, let's see what we got. So we've got the sysmon config. That should be fine. Okay. We did that. Oh, there's more. A new rule needs to be added to local rules.xml in the Waza manager to watch the sysmon event generated by the execution. Wait, this is just PowerShell. But that's just PowerShell. Otherwise, we did everything right. Unhelpful. All three applications have full support for sysmon parsing. In fact, the way we do sysmon parsing is we normalize the logs and pass it off to the sysmon parser, so all three go through the exact same parsing. If I'm reading this correctly, we've done everything correctly. Let's go to our overview. Nothing. Dashboard. Let's go back to sysmon. Oh, is it because the time... Look at the timing. That might be why. It should be to now. Or like to 1300. Oh my god. All that because the time range was half an hour prior when we got sysmon running. That is something I keep running into with Kibana. And it's just like something, or yeah, it's just something to be aware of. But yo, look at this. Now we've got a lot of stuff going on here. We've got sysmon running. This is great. Now, I know the stream's running a little long, but let's run our malware again and see what happens. Ah, no, get out of there. Almost ruined my day. Infected. All right. Hold on to your butts. Wait, is Defender on? Defender's not. Yeah, we turned it off. Awesome. Okay, here we go. Now, we're gonna just look for all alerts now, right? Because we're gonna go... Any indicators? Let's look at alerts. Successful authorized event. This is app armor denied. Okay, we need to... Okay, here we go, here we go. Now we're starting to look, these are our alerts. Yeah, the completion is much better than it is in Splunk. Really, really nice. Okay, we've got some medium alerts here. Let's take a look at our medium alerts. Windows application error event. What you got for me? That doesn't seem that special. Storage optimizer. Let's go look at all of our alerts coming from our friend, Flare. And actually, this is our sysmon. Like, let's take a look at what we have going on here in sysmon. These are our... Oh, event.dataset is how we would do it. That's really cool. Okay. So can we do that here? So agent.name Flare and event.dataset. No, wait, sorry. Just kidding. Because that's not going to get us everything. Event.module. Here we go. Okay. Now we're cooking with gas. Look at this. So now we're seeing explorers firing off. All right. And then what we want to do is we want to start adding columns here to our... We know that it's sysmon. We want to see some specifics, right? So maybe we'll add the... We'll toggle the column. So we'll add this column. We'll add the process parent. We'll add the PID. The directory, definitely. That's going to be cool. And the user. And can we get the event ID? Event ID. Yes, there it is. Okay. So that looks wrong. Right? Now, was that 02? Was that the name that we originally... Yeah, that was our kickoff. 25. 25. Yeah, so... Let's see if anything else has come in since then. Yes! Ooh. Some of these are empty. Because these are event ID, what, 13? What is sysmon event ID 13? It's a registry event. So we want to watch for some of those as well. But let's even just look at what is the column? Ross winlog.eventID. Event ID underscore. All right. So these are just processes that are starting, right? We're seeing services. And this tracks a little bit with some of what we saw. Oh, I closed some of the evil that we saw here. Look at that. Local service network restricted. And then we'd expect maybe run rujnqu or something like that, .exe. Coming from C Windows, interestingly, right? So it's not coming from C Windows System 32. Okay, so this is right here. This is where I executed the evil. Right here. Then we saw some Windows servicing stuff happen. Trusted installer. What's this about? Net services. I think we need to learn a little bit more about what GhostRat does. What do you have to say, Trend Micro? So drop ctfmon1.exe and this DLL. So there's going to be stuff that's in registry to deal with. Oh, cool. MITRE has it. So we'd be looking for some DLLs. We'd be looking for registry changes. So client starts our updates. Okay, so let's actually look at registry events then. And I'm going to have to change up the columns that we're working with because we configured this to do command line. Instead, we need to look at the registry target object. And yeah, that looks pretty good. So we're seeing your control set services start. We're seeing kind of exactly what we thought based on current version, control set services. And sysmon 13 is value set. Yeah, that's right. That's what we wanted. Can I see the value that's getting set? WinLog data details. That's what I want. So now we'll see both the registry key that's set and the value. Very cool. Okay. I think that's going to do it for today's stream. So we've been able to get sysmon talking to Security Onion. We've been able to install some malware, which I'm going to revert our machine back to a pre-malware checkpoint here. But otherwise, we're pretty much sorted. So I think that's going to do it for today. Let's see if we have any place cool to send everybody. Who else is streaming today? I really wish there was a way to raid from the Streamlabs interface. Oh, Nahamsec is streaming. Okay, well, I feel like that's something we could obviously send folks to. So, all right, I'll send everybody to Nahamsec if you want. But thanks everybody for hanging out. I'll be back on Tuesday with some offensive stuff. Haven't figured out what I'm going to do on Tuesday yet, but it'll be more red teamy. So until then, be good to yourselves, be good to each other, and happy hacking, everybody.